Hello, Maurits here again. So we had a definition here of derivatives, right? That f prime of x equals to the limit as h goes to 0 of f of x plus h minus f of x divided by h. And we have already found that, for example, we tried this with the functions f of x equals to 3x plus 2, and we found that the derivative is 3, just like expected, since the derivative should be a function that gives us the slope, and the slope of 3x plus 2 is 3. And then we tried the function f of x equals to x squared, and we found that f prime of x equals to 2x. So let us have a look at a further example. Say f of x equals to x to the power of 3. So that means that f of x plus h equals to x plus h to the power of 3. And that means that our derivative should be the limit as h goes to 0 of f of x plus h, that will be x plus h cubed minus x to the power of 3 over h. And we can already see a pattern here that if we try to plug in 0 to this, we will get 0 over 0. So we need to simplify this. And if there's some polynomial going on here, we try to expand that first and see what happens. So the limit as h goes to 0 of, and we expand this, that will be x to the power of 3 plus 3x squared h plus 3xh squared plus h cubed minus x to the power of 3 over h. As before, we see the x to the power of 3 will cancel against x to the power of 3. And we then see that we have the limit as h goes to 0 of 3x squared h plus 3xh squared plus h to the power 3 over 3. But here we can see that we have a common factor h, as we had with x squared. So we can take that factor out here. So h, and we get 3x squared plus 3xh plus h squared over, oh, and that should be an h there, right? Sorry. Over h, and the h and h will cancel. And what will that give us? That will give us the limits at h goes to 0 of what we have here. So this part here, right, within brackets. And if h goes to 0 there, we end up just with 3x squared. So, I forgot to put a derivative over here too. So the derivative of x to the power 3 is 3x squared. So that's rather nice. If we look at some more general things, let's say we have another function, g of x, that is a constant times f of x. That means that g of x plus h equals to constant times f of x plus h. So our derivative of g of x now, so g prime of x equals to the limit as h goes to 0 of a constant times f of x plus h minus a constant times f of x over h. But here we can see that we have a constant k that isn't influenced by h, so we can factorize out that and actually put it before the limit. So we get a constant times a limit as h goes to 0 of f of x plus h minus f of x over h. But this thing here is nothing else than f prime of x. So we have actually found our first little bit more general rule, and that is that if you have a constant times a function, take the derivative of that, we just keep the constant and take the derivative of our function. So for example, if we have that our function equals to, say, 3 times x square, then the derivative of this should be, and we have a look here, okay, we should keep the constant, so that is 3, and we know the derivative of x square is 2x, so in other words this will give us 6x as our derivative of 3x square. Can we make some more general rules? Yes, of course. Say we have that our function, say we call it now h of x, is the sum of two functions. That means that our derivative of h of x equals to the limit as h goes to 0 of f of x plus h plus g of x plus h. So that is h of x plus h, right? Minus f of x plus g of x. And then we divide that by h. But we can rearrange this to the limit as h goes to 0 of f of x plus h minus f of x, divide that by h, plus g of x plus h minus g of x over h. But we can see that this one, when we take the limit of that, will be f prime of x, and this one here will just be g prime of x. In other words, we have yet another rule that if we have f of x plus g of x and we take the derivative of that, we can take the derivative of the two functions separately. And if we try to have a minus inside there, do the same thing but one function minus the other. If you try that, you will find that we can just have the rule written like this. Quite often you can see the rule written like this, that the derivative of f plus minus g equals the derivative of f plus the derivative of g without any bracket x on it. Let's look at an example. Say our function f of x. Remember now that f of x is not the same function through this. Let's say our function f of x is x, we can say here 2x to the power of 3 plus x to the power of 2 plus 4x minus 6. So we can use the rule we just found out over and over again. That means that we can take derivative of these separately. So f prime of x, we'd need to take derivative of the first term, and by the rule we just found out before, this rule says that we can keep the constant, so we keep the 2, take the derivative of x to the power 3, and we found that earlier to be 3x square plus the derivative of x square, which is 2x, plus the derivative 4x minus 6, and that's just a straight line with a slope of 4, so that will be just 4. And that can be simplified to 6x square plus 2x plus 4. And now we found a derivative just through using derivative rules without having to resort to the definition of derivatives. So hope this helps. Thank you.